Hello everyone. Today we've come to the Tea Research Institute of the Chinese Academy of Agricultural Sciences to visit Professor Zhu Yin and her team. Let's take a look at what kind of research Professor Zhu Yin and her team are working on. Let's go! So, how did you transition from organic chemistry synthesis to working in the field of tea flavor research?
Because after I finished my PhD, I really wanted to move from working with bottles and jars in the lab to a more dynamic and lively work environment. At that time, it just so happened that our Tea Research Institute was hiring. At that moment, I felt like my DNA was activated. For us people from Fujian, we have a very deep emotional connection to tea. We Fujianese can go without a dining table, but we can't go without a tea table, or you could say a tea set. Basically, tea is indispensable in our daily lives. So I felt that this industry was both familiar and unfamiliar to me, and at that time, I wanted to come into this field.
So in daily life, what are the most common or frequently asked questions people ask you?
Sometimes when I take a taxi to and from work,
right?
The drivers often ask me on the road. Sometimes they might feel a bit shy to ask, but at the end, they'll suddenly ask me, so what's there to research about tea? I'm curious. They ask, why does tea even need its own research institute? Especially when I tell them that at our Tea Research Institute, my own research focus is on tea aroma, they're even more surprised. Aroma in tea is invisible and intangible. Why would you study that?
When it comes to Baiju, there are many aroma types that everyone is familiar with. Right, like sauce aroma, strong aroma, and light aroma, right? As for tea, could you introduce some of the products to us?
The aroma types of our teas differ based on their processing characteristics. For example, green tea tends to be fresher and lighter, so its main aroma is a fresh scent, and the higher quality ones can have an orchid fragrance. Yes, orchid fragrance. For black tea, the basic tone is a sweet aroma, but if it's a special variety or crafted with exceptional skill, it can also have floral and fruity notes, or even a longan aroma. So our aroma types are very rich. As for white tea, there's this kind of rich aroma. How do you
analyze these aromas?
Maybe the older generation when making tea would judge the quality of the tea based on, most of the time it was by smelling it themselves. Now that modern science has developed to this level, even though it's still hard for us to fully grasp the actual substance of aroma, we can use all kinds to separate them out and identify the key compounds responsible for a particular aroma profile. Out of 400 or 500 or even more components, we can identify maybe a few dozen that actually contribute to the detectable aromas. Then, after characterizing them with instruments, we can pinpoint the compound most closely associated with that aroma type. We can then apply this knowledge to tea production or tea evaluation. This is the overall process of sensory evaluation of tea aroma that we conduct. This platform is what we use to conduct comprehensive molecular sensory studies. First, we start with an overall sensory evaluation of the aroma in the industry, assessing it based on 5 factors: the aroma and taste of the tea, the leaf base, the tea liquor, and the appearance. By evaluating these 5 factors, we can determine its characteristics. Next, we move over here to specifically carry out aroma extraction. After extracting the corresponding components, we then use this equipment to analyze some of its chemical constituents. The first is green tea, the second is black tea, the third is oolong tea, and the fourth is aged white tea. For the aroma evaluation, we pick up the cup, and as we bring it closer, we take a sniff. Let me demonstrate. Okay, first, give it a couple of shakes. Then smell its aroma again. Then put it down and you can experience it. Give it a shake first. Then slightly lift the lid of the cup. Take a moment to carefully appreciate its aromatic characteristics. This one should be a fragrant type of green tea. You can also smell the black tea. Black tea has a bit of floral and fruity aroma, and its main note is a sweet fragrance.
Wow, it's a completely different scent. So these are the different aromas.
Smell.
After smelling it, how can we determine what specific compounds are in here?
At this point, we need to use a pre-treatment technique for aroma extraction. First, we need to extract the aroma compounds from the tea infusion. After extraction, we then load them onto this equipment. Right now, we're doing a routine aroma extraction. From the sensory evaluation we just did, we've already selected a few tea samples that we think are representative. Yes, they can represent the most characteristic aroma types of the tea samples we want to study. So now we need to carry out an extraction. For the extraction, the classic method is to put it into this small vial. The ratio of tea to water, including the initial aroma and the amount of tea leaves used, are all parameters we've already screened and determined beforehand. With this method, first we grind the tea leaves into tea powder. Then, we put the powder into a headspace vial. After placing it in the vial, we brew it with boiling water. Once the brewing is done, we then take our SBSE extraction stir bar and place it into the vial. Typically, we extract for half an hour. After half an hour, we remove the stir bar from the vial, rinse it, and then we can put it onto the instrument for analysis.
I see that you have published around 48 papers, and in many of these papers you mention chiral molecules. So what exactly are chiral molecules? How do they contribute to tea research, and what benefits do they bring to subsequent processing techniques?
Actually, tea is just like our two hands. They are like the left hand and the right hand, but they can't overlap each other. They can only
mirror each other?
That's right. So our tea is the same way. Its DNA determines that it will have certain specific proportional relationships. For some varieties, one configuration may dominate, but for another tea, depending on the variety or the place of origin, it may show the opposite configuration. And these two compounds, in fact, when it comes to their aroma types and odor thresholds, there can be huge differences, sometimes even up to several hundred times.
Wow, so it's like a pair of twin brothers with completely different personalities, isn't it?
Yes, exactly. That's why we need to regulate this ratio in tea as well. First, from the perspective of breeding, we can look for aroma types that we like and selectively regulate them so that the plants specifically produce these more pleasant aroma configurations. Alternatively, we can also achieve this by working on certain aspects. We can also use this for tea identification, such as product or origin authentication, or for tracing the variety, as well as for work related to quality and safety. These are all things we can do.
So with the identification and research of these chiral molecules, it could potentially help with tea breeding, right? It could be helpful.
Yes.
And it might also help with processing and distinguishing the origin.
Grades.
It can serve as a reference for quality classification, right?
Yes, exactly. From a chemistry perspective, it might be that we should be able to combine something as everyday as tea with chemistry. I think it's still a very worthwhile area to explore, and what we've done so far is still quite preliminary. There's a lot more we can continue to do in this field.
That's wonderful. I never expected that such a small tea leaf could hold so many mysteries and that it would require so many of us to study and continually explore it.